Hey guys, welcome back to the academic powerhouse with your mathematical meathead himself, the realest guy in the room. Bada bing, bada boom. How you doing? How you doing? Let's pick up right where we left off on the last video. And to refresh our memories as to what we even talked about, we're talking about statistics. We talked about the idea that it is all about telling a story of truth through the collection, analysis, interpretation, and the presentation of data. We talked about collecting data through statistical questions. And we also identified that every statistical story has three key elements to the story, which is the primary focus of this video. It is all about I'll even the three elements: center, spread, and or variability, as well as shape. Now, the nice thing about math is that we can calculate. We have ways to calculate the center and the spread. And when we do so, it will tell us what the center and the spread are, yes, but it also give a sense as to the shape as well, which there you go. There's your three elements: center, spread, and shape. And so when we use math, we can begin to tell the story that we want to tell, the story of truth. So before we calculate anything, before we present anything, and before we can really move on to step two of the process, which is analysis, I want to interject here and talk about the certain types of calculations for center, the certain types of calculations for spread. These are known as, I'll scroll down a little here. So for center, these are known as measures of central tendency. And I'll write down here variability is are measures of, you guessed it, variability. Now let's remind ourselves center and variability, what these terms mean. Center is what it is describing is where most of your data points are gathering around. So say for example, the average height of a US male adult, 5'10", right? 5'10". That's now not everyone is 5'10". People are shorter, people are taller, but the average is 5'10". So, and you can use that for any sort of data set that you're trying to look at and statistical story that you're trying to tell, right? There's always going to be that summary, that the number that can summarize your data. So that's an example. There are a couple of different measures of central tendency, and I'll talk about these before we dive into variability. So know these. You may already know these, but these terms, I'll talk about each one individually. We got, of course, the average, which is also referred to the mean. These terms, they are the same thing. You'll see them used interchangeably. Recognize them for what they are. And so let me write the other two, and then I'll talk about each one separately. The second measure of central tendency is median. Median. And the third one is mode. Now let's talk here. Let's talk here. What is an average? What is the mean? So when you see these terms, I want you, before we start calculating, I want you to be able to immediately recognize what it is, what they are, and that they are all measures of central tendency, which I'll even write here on the side. It is, um, let's see, numbers to describe and summarize the set of data. In fact, both the measure of variability and the measure of central tendency both describe a set of data, although this one, but again, I'll talk about that here in a second. Anyways, numbers, or even just plain old number. No numbers, because we're talking about three. Anyways, average and mean, average and mean. So I'm going to write this out here. I'm going to use A for average, right? I'm going to set up a little equation. We love equations. We're familiar with equations now, right? But average, all the average is, in order to find out what the average is you look at your set of data after you've collected everything. So hopefully you've asked your statistical questions. Hopefully your computer has recorded all sorts of different data points as it relates to your statistical question and generates the points. But basically what you do to find out the average and the mean is you take the sum. Again, a sum means adding everything up. So take the sum of all your data points and this is supposed to be a straight line, guys. And you divide, right? The straight line being divide. So you add all your numbers together and you divide it by the count of data points that you have. Equals some number, right? That's really what an average is. And perhaps maybe it's intuitive to you, but seeing it laid out like this certainly will help us as we work through example problems, right? As I said earlier, the average height of a US male, 5'10". Okay, they counted up they counted up every guy that they surveyed. They took each and every one of their heights, added them all together, and then divided by the total number of participants in that survey and extrapolated that out to apply to every single male in the United States. We'll work through a problem. You'll see exactly how this is done. Okay, but understand that's really what an average means, right? So median. Let's talk about median. Let me do a different color here so we don't, just to keep things visually interesting. A median. A median is when you organize all of your data points, so all those heights, and you put them in order from least to greatest. And then you literally count which one's in the middle. And the middle one, after they're all lined up, everyone's in a line, the middle person in that line. So less about calculating and more simply just organizing, right? There's some calculation to it, of course, but I'll give you a short little example here, right? So let's say I've got 5 numbers here. Let's say I got 2 and a 5, 7, 10, 11. I put them all in order, but you can see here, right? There's one number, 2, 3, 4, 5. The middle one, the one in the middle in this little quick example, 7. So I would say my median is 7. We'll do a lot more complicated examples. It's not always going to be this simple. For example, if you have no clear middle, you have to make a middle or calculate a middle, which we'll get into a little bit more. Mode. Mode is another measure of central tendency, and mode is all about, again, it's less calculated. In fact, there's no calculation whatsoever. Mode is simply recognizing, pattern recognition, recognizing that, let's say you have a data set. So let's make up another one here. Let's do, here I just made one up. Mode is recognizing the pattern, a particular pattern. Mode is saying that what's the most common number in this data set? The most common. So if I look at this one that I just kind of made up on the fly here, well, I can see that there's only a 1, 2, there's only 1, 1, there's only 1, 3, and so forth, but I recognize there's multiple 6s here. There's 2 different 6s, and there's only 1, 7, 1, 8, 1, 10, 11. There's 2 different 6s. So what it is saying is, okay, that is my mode. That is the most common number. That is the number that appears the most amount of times in my data sets. So less on the calculation here, more just on recognizing. You don't have to organize it like median, although that could probably help. Just recognize. Just recognize. So if there is anything to take away here, measures of central tendency, take away that there are 3 of them, and at a high, broad level, what they are. Okay, let's talk about measures of variability real quick. There's a few of them. And again, as I said, calculating the center, calculating the variability, it's going to help give us a shape. And when we have all 3 elements together, we then have a statistical story of truth to tell. So, what are some of these measures of variability? There's a few. I'm only going to talk about the ones that are going to be most applicable to us and you. Most common one you'll see is range. Range. Another common one you'll see is interquartile range. And you'll see, again, for you guys, we'll see mostly mean absolute deviation. Or you can call it MAD, I guess. MAD. Anyways, let's talk about each of these real quick. They're not super hard to understand, but again, variability is how well, think of it like this. If you have an accordion, right, an accordion that you have in your hands, you can, or even a slinky, right, you can pull it apart, you can push it all in together, pull it apart, push it in, the whole thing spreads out, the whole thing compacts together. Variability is the idea that things can be spread out. How far are they spread out from the very center? When you pull the accordion apart, when you pull the slinky apart, it spreads out. It's more variable. It's got a greater amount of spread than if you were to simply just push it all in together, right? So variability is, well, it's spread. It's spread. And if you remember our curves from before, whoa, okay. If you remember how on the last video, how I drew some curves, We had some that looked like this. Let's pretend, I'm going to draw two side by side here so you get the idea. Let's imagine that these both have the same central tendency value. All right, let's say that the average is let's say it's 3. We'll also say the average here is 3. And the difference between one that is highly variable and one that is not is spread. Maybe I'll redraw that a little bit here so it's more clear, right? But here we go. Looks something like that, right? Looks something like that. That's an indication of variability. You can kind of see here on these sides, these long sides here, right? I have data points out here, way out here. Here I didn't have, as they all ended right here, right? Fairly close to the center, and these ended so far away from the center. That is variability. It's the spread. Again, think of the accordion, think of the slinky. The further out that it is from the center, the measure of center, means that it's more variable. So the common ways that we go about calculating variability, range is, it is a calculation, but it's a fairly simple calculation. It's all about taking the maximum number and subtracting the smallest number, right? So let's see. I talked about height of U.S. males. I said the average was 5'10". There are some guys out there who are crazy tall, right? 7'3". Wow, 7'3". There are some people out there who are, um, I'll just say 4 foot. I know there are people even shorter than that, but I'll just say 4 foot. There's a lot that's a huge, right? There's a lot in between. There's a lot in between, right? So even though we're saying 5'10" is the center, we're saying here when we calculate our range is that, let's see, what we're saying when we calculate our range is that we're saying that the height of U.S. men could be anywhere between 7'3" and 4. We're saying that there is a spread of men who are as tall as, or there are a spread of men who can be in between these heights, from, and there's a 3 foot 3 inch spread of all the heights, is what I'm saying, guys. So, and anywhere in between, so 4'1", 4'2", 3, 4, 5, etc. They can all be spread out. So our data points can be all spread out within that range. Interquartile range. Interquartile range. It shares a key term here. And for the most part, it is similar idea. Although when you say interquartile range, it has a little bit more of a focus on where most of your data is. Whereas range is, the focus of that is on where all of it's at. So you'll see interquartile range most commonly. Hold on, where's my pen at? Hold on, gotta find my. Here we go. Hold up. Hold on, my pen. No, my pen. Hold on, let me restart it here. Hang on, it's restarting here. All right, okay. I don't know what happened there. My pen cut out. Anyways, you'll see interquartile range most commonly associated with box and whisker plots, which we'll get into in a future video here. But the difference between, well, actually, so range range, this on when we talk range, this would be the smallest, and this would be the largest. The difference between interquartile range is that it's saying, I don't care about these whiskers and all this long tail and these outliers here. It's saying that I'm just going to focus on where most of the data is, which just happens to be here. This is the smallest, and this will be the largest in its calculation, right? So again, when we do example problems, I'll get more into this, but understand there's a difference and understand that an interquartile range is referring to the difference between the smallest or the maximum number and the smallest number within a very concentrated area. And so the last one I want you to understand as far as measures of variability, mean absolute deviation. Mean absolute deviation is all about, how do I best describe this? This is all about, let me do a dot plot here to better illustrate and get you comfortable with the idea. And I'll do 5. Let's say, so here's my middle, 1, 2, 3, 4, 5. Mean absolute deviation is saying that, let me draw this out first here. Mean absolute deviation is saying that everything that's not in the center, so this one here, I'll label this even more clearly. Let's say this is 3, this is 2, this is 1, 4, 5. There we go. It's saying that everything that's not in the center exists some distance away from the center. It could be in this direction, it can be in this direction here. But what it's saying is that there is an average, that's why it's important to remember average, how to calculate that, sum of data points divided by the count, hint, hint. It's saying that, there's going to be a distance away, right? Most where the average amount of your data points are. Um, when I talk about, I'll even break it down into smaller steps here. So let's focus on the green here. Let's focus on the green. And then I'll do this one here. But if I were to say, so if these were gone, let's say, for example, these were gone. Okay, let's say that these data points at number 4, they are a distance of 1 away from the center. So 4 minus 3 equals 1. And these bars here are absolute value bars. It's just saying that whatever comes out is positive number. So 4 minus 3, 1. 1 equals 1. Positive number, positive number. Anyways, it's saying here that, look, the deviation is 1 away. Similarly, on this side, 3 minus 2, or I'll even write it the other way so you can see the absolute value piece at work. It's saying that, well, I can look visually, it's 1 away. It's 1 away, 1 away. So 2 minus 3, negative 1. And then, of course, absolute value means anything negative in here, whatever's negative, just comes out positive. Okay, so we'll get more into the, I don't want to go into full calculation mode. I just want to introduce the idea that a mean absolute deviation is, all it's saying is that it is the rest of the data points are some fixed distance away from the center on average. So remember the three measures of variability. You got range, interquartile range, and mean absolute deviation. These are what's going to, you'll see most often as you go into higher level math. You'll see other things. You'll see variance. You'll see standard deviation. And like I said, you can calculate these. You can calculate these variability measures and center measures and get out. Um, you can use those calculations to then determine a shape. When you have all three elements together, that allows you to tell a statistical story. Rather than look at a bunch of data points in a boring old notebook or a boring old piece of paper, you can simply have a summary. You can summarize your findings. You can summarize and say, for the heights, for the heights. That's why I can just tell you that the heights, I'll say average equals 5, 10. And as I kind of used in my example earlier, um, I'll say variance, even though that's not the exactly correct term. I'll just say, or even I'll say um, variability. Right? I said it was 3, 3. Right? That's why I can simply just say this. And I can give you an image of what that would look like. So here's, just a standard curve. It's normally distributed, normally because it all conglomerates here in the center, right? When you get in higher level math, you'll see that it's not always the case. It could look like this, or it could even look like this. But for us, so all I can do, rather than, like I said, look through a bunch of boring pieces of paper with data points and tables and all this crazy stuff, I can simply just give you a summary, and a little visualization, and that will tell the whole story of what we've deduced about the height of US males. So that is how statistics is valuable. That's just a small sampling of how statistics is valuable. But the key takeaway, once again, guys, know that measures of central tendency, average, median, mode, measures of variability, range, interquartile range, and the mean absolute deviation. You know these, and that's the main purpose of this video here. So with that said, I hope we've got a good pump on today. I hope we've burned a lot of good mental muscles today. Feel that burn, baby, because guys, we got more. We got more to do. We have more iron to pump. We've got more muscles to build. So see you in the next video. Take care, guys.